So for this multiple regression example then, so the idea is you fit the model in the usual way. So what you have in the first line is y is related to the set of x variables, and the x variables are separated by a plus sign. And again, whenever you think about using R and how it works, think R for robot. So you run the command, in this case a.lm goes to the linear model, and then you need the summary command to actually show you the results. Now, as with all these different softwares, R will produce a lot of irrelevant information. The obvious things to look at here are the R squared statistic, the individual T statistics, and the S statistic to assess overall fit. Okay, and then necessarily what you see here with a multiple linear regression example is there's more going on here when you look at part 2, the individual T statistics, and part 3, the F statistic to assess the overall fit. Okay, and it is possible that this F statistic calculated in part 3 may not necessarily tell you that much useful information, but as we will go through the next lecture, the F statistic can actually tell you quite a lot in slightly different context if you change the format of the test slightly. So in terms of interpreting our output then, so remember R or any other software will produce a lot of information, not all of it will be relevant, and the value added that you provide is picking out precisely these sorts of nuggets of useful information. So in terms of the R squared statistic then, so R just tells you this thing here, R squared 5. R squared is very high, which suggests we might have a good model. So if you take this at face value, this suggests that the model explains around 99.6% of the variability in the data. Now, whilst this is high, very high, and R squared wants to be as high as possible, there's a slight chance, however, that this is potentially too high, and too high to be true. Okay, so there are occasions where high R squared values can be misleading, and we'll go through these later on in the module. Okay, but certainly there seems to be quite a lot going on here, and certainly these x variables, at least something seems to be related to the y variable in question, the number of employed people. Okay, so the other thing I ought to say here is that just be a little bit suspicious perhaps of models that explain 99.6% of all the variation. So again, R or any other computer software package will produce a lot of information, not all of it will be relevant, and the value added that you provide is your analysis and picking out these useful nuggets of information. And the second thing are the T statistics. So for this course, you tend to just look at the variables for which P is less than 0.05, and that's certainly a nice way of setting exam questions on a formal written exam. In project work, however, this sometimes gets a little bit more nuanced, and the interpretation can be quite different, and you might, for instance, find things like p-value satisfying p is bigger than 0.05 and 0.1 might give you weak evidence of an effect. Okay, so it's not definitely formally statistically significant at the 5% level, but it might still be potentially interesting. And also, I think that if you have this, the p-value is between, can get quite ambiguous. You haven't got the surety of interpretation if you just look at this hard and fast. If you analyse results carefully, it's possible for real projects the interpretation gets more nuanced than the natural thing to look at, which is just p less than 0.5 for exam type questions. What's given by R suggests not all of the variables are statistically significant. So if you run the example yourself, a shortened version of the results given by R is roughly something along the lines of what's on this slide, and then again, what I was trying to get across to you before earlier in the lecture, what you want to do here is look at the second row of this table downwards. The default option is that you usually fit an intercept or constant term, so the first row isn't really very informative. It's the second row of this table downwards where the action lies. Okay, and then these asterisks denote things that are statistically significant according to this T statistic. So ignore the first row, but this would suggest that the T statistic gives you evidence of a relationship between x3 and y, x4 and y, and x6 and y. Okay, and if you haven't got any asterisks, then this is instead an indication that there is no statistically significant evidence from the t-test that there's a relationship between first x2 and y, and secondly x5 and y. Okay, so this is perhaps something that you might expect to find in a multiple linear regression example, that there is clearly some of these x variables are related to the y variable in question, but not necessarily all the x variables are needed in order to give a description of what's going on and what is happening in terms of the correlation of these x variables and the y variables. Interpreting these t statistics then, so the t statistics show that not all the variables are statistically significant. So the action here happens from the second row in the table downwards. So the convention is usually to include a constant or intercept term in the model. So this first row of the table of t statistics isn't really very informative. The p-value suggests that the x variables x2 and x5 are not statistically significant. So p is bigger than 0.05, and if you look at the data display in R, these aren't accompanied by an asterisk. So in this case, the sign is irrelevant. There's no formal statistical evidence of an effect. And then in contrast, the coefficient of x3 is negative and statistically significant, precisely because p is less than 0.05. Visually, you have an asterisk beside the x3 in the table, and this would indicate that as the number of unemployed people increases, the number of employed people decreases. So almost a complete truism, but at least you haven't got an obvious contradiction at this point. Okay, and what I should say here is that write this down the opposite way so you work it out. So it's significant, then is it significant? Write it down the opposite way. It's negative and statistically significant in this case. So again, you tend to write it down the opposite way to work it out. So the coefficient of x4 is negative and statistically significant, precisely because p is less than 0.05, and again you've got an asterisk beside x4 in the table. So in this case, the interpretation would be that as the unemployment rate increases, the number employed decreases. So again, a complete truism, but at least you haven't got an obvious contradiction at this point. And then you're given here that the coefficient of x6 is positive and statistically significant. So x6 is the time trend, so this suggests that the number employed is generally increasing every year over the period in question. Okay, so I don't think there's necessarily much you can sort of read into this coefficient of x6. Perhaps you might see that the employment rate is generally increasing over time, and you might argue, I suppose, if you squint carefully, that this is not necessarily to be taken for granted, and perhaps the data in question has been collected over quite an unusual period in economic history. Okay, but yeah, quite a systematic line-by-line approach. Is the thing statistically significant? And if it is of these graphs that we've seen before. S statistic for assessing overall fit then. So according to R, you have this S statistic here, 8.8 degrees of freedom, and the associated p-value less than is just 2.242 times 10 to the minus 11, which is much less than 5. So this presents very strong evidence that at least one of the x variables in the study affects y. So there's clearly at least something in these sets of x variables that affects y. However, perhaps you don't need all these individual x variables in the model? For instance, do you really need to include both the unemployment rate and the number of unemployed people in order to estimate the number of people who are actually employed? Okay, so there's certainly something going on in the sample. However, it's probably not sensible to fit the model with everything in it. So you need to think more carefully about how to test hypotheses and choose a model to explain the number of employed. Okay, and in this case, the F statistic is making sense in the context of a practical problem, in the sense that the data collected clearly has some predictive value for the number employed.